Alright, so today we're going to be doing 15.3, which is determinant and inverses. Alright, so for every n by n, a square matrix, A is associated with a real number called the determinant. So we're only going to be doing determinants for 2 by 2 matrices in this class. There is a way to get determinant for bigger matrices, but just not in here, okay? We're not going to go to that point of difficulty. Alright. So, in order to find the determinant of a matrices that's 2 by 2, you're basically going to multiply together the upper left times the lower right minus the lower left times the upper right. So like diagonally is how you go. So that's how you get the determinant of a matrices, okay? So with that, this is like the official definition of it and how to see what we're multiplying together. So this times this minus this times this. So we're going to just practice finding some determinants before we do anything else in here. Okay. So this one right here is going to be 1 times 4. And it's always minus with the determinant. Negative 2 times 7. So that's going to be 4. Now this is going to become plus because it's a negative times a negative. So what is going to be our answer here? 18. So 18 is what we would call the determinant. Pretty easy, pretty straightforward. Okay. One more just to make sure we have a good idea of what to do. So it's going to be 5 times negative 4 minus 2 times 6. So that's negative 20 minus 12, which is what? Negative 32. That would be our determinant. So does everybody see how to find the determinant and feel pretty good about it? All right, perfect. Next one we're going to do is we're going to talk about something called the inverse. So the inverse of a matrix is similar to the multiplicative inverse of a number. When a matrix is multiplied by its inverse, it produces something called the identity matrix. So the identity matrix always looks like this. There's identity matrices for all sizes, but it's basically just when the diagonals going from left to right downward are always 1, and all the other numbers in the matrices are 0. Does everybody see how that pans out here with the identity matrix? And we call the identity matrix letter I, capital I. So the rule is, if you take a matrices and multiply it by its inverse, the answer will always be the identity. Okay? The answer will always be the identity. So these are the steps to finding the identity matrix. So step 1 is to find the determinant of the matrix. You guys know how to do that. We learned about it on the last slide. Step 2 is to swap the positions of A11 and A22. So these are literally going to swap. You're going to then change the signs of the other diagonals. And then you're going to divide everything in that matrices by the determinant. So of course we're going to do some examples of this, but there is a little bit of like a phrase that you can help remember what the steps are, okay? So I'll write it out here. Diagonals, top to bottom, swap. So if you see here, these guys, they swap. Diagonals, bottom to top, signs drop. So I'll just explain what I mean by that with this example. So as you can see, diagonals top to bottom, they swap, okay, with each other. Diagonals bottom to top, these guys, the signs drop. So whatever sign they currently have, if they're negative, they become positive. If they're positive, they become negative. Okay, so that's like a little phrase to help you remember, but you can remember however you want to remember. So any questions about that? All right, take a second if you need to get it down and look this over. The 1 over, this is basically 1 over, this is the determinant, by the way. So it's always basically multiplying by the 1 over the determinant or dividing by the determinant every time. Okay, so let's go ahead and do an example together of how to find the inverse of a matrices. So if you're trying to find the inverse of a matrices, step 1 is to find the determinant, okay? So the determinant is always going to be this times this, minus this times this, So our determinant is going to be -6 plus 10, which is 4. So does everybody see how I got the determinant to be 4? Okay. So now what you're going to do is you're going to do 1 over whatever the determinant is. That's what's going to go on the outside, what you're going to multiply in. And then you're going to put in a new matrices. And this is the matrices you have to use those rules on, okay, to swap things around. So if we look at this matrices right here, we're going to apply the rule, okay? Diagonals, top to bottom, swap. So these guys are going to swap positions. So everybody good with what we did there? Okay. Diagonals bottom to top, their signs drop. So this one's a positive, it's now going to be a good. And this one's a negative, it's now going to be a positive. Now what you're going to do is actually multiply everything by the 1/4 or divide by 4. So this is going to be 3/4, -5/4. 2 divided by 4 is 1/2. And -2 divided by 4 is -1/2. So what we just came up with right here is what we would call A inverse. It's the inverse of the matrices A. So do we have any questions about how we got that matrices? You guys understand the rules, what switch, what determinant came from, all that? Okay, so now on part B, what we're going to do is we're going to prove that this is the inverse. So to prove that this is the inverse, you basically multiply the matrices by its inverse, and it should come out to be what we call the identity matrix with the diagonal ones. So we're going to try that. So down below, it wants us to show that the product of A and A inverse is equal to the identity. So we're going to do that. I'm going to write what A and A inverse are down here just so it's easier. So we got A. And then we have A inverse. I just find it easier when they're written out. So we got 3/4, -3/4, and 1/2 and -1/2. Alright, so now we're going to do matrix multiplication. You guys all know how to do this from your last quiz, of course. Sure.
Where'd you get -3/4 on the bottom?
So if we look at this, oh, you're right, it should have been -5/4. Thank you. I just copied it down wrong. So thanks for catching that before we had done the multiplication. That would have been way more difficult to catch later, so I just copied it down wrong. Yes, you had a question? No? Okay, I thought you raised your hand. Alright, so now we're going to do the multiplication. So if you guys recall, you're going to multiply the first row by the first column, and that's going to be our first position. I'm going to just, I wasn't wrong, I'm just going to write it differently, because it's just, I like to put the ones that are in the column in the parentheses, because it's just easier. And then we're going to go and do the next row with the same column. And then we're going to move on to the next column. We're going to go back to the first row. And then the last one, last row times last column. All right, any questions about that? So now we're just going to go ahead and simplify this. So I guess I'll do it over here so we have enough room. -2 times 3 is -6. -6/4 would reduce to what? -3/2, right? So that's -3/2 plus, this is going to be a +10, so it's plus 10/4. What is 10/4 reduced to? 5/2. Okay. Now this one here, this is going to be 15/4, and then this is minus 15/4, right? This one over here, this becomes a -1, and this becomes, this should have been a negative, by the way, sorry, +1. And then this becomes 5/2 minus 3/2. So does everybody see how I got those? Just multiplying out. Now we're going to see if we can reduce this. So what is negative 3 halves plus 5 halves? 2 over 2, right? Which is 1. Anything minus itself is what? 0. This one up here is going to be? Good. And then down here? 1. So this right here is what we call the identity matrix. It always looks the same. And if you do not get this when you multiply two matrices together that are inverses of each other, you know you did something wrong. Does that make sense to everybody? Okay. All right. So for the next one, we're going to do the same thing we just did. It's just another practice problem. So what I'm going to do is I'm going to go through, I'm going to do this whole problem with you, B, and then I'm going to have you guys try to confirm the identity on your own, and then I'll show you the steps. So first thing we got to do is we got to find the what? The determinant, which is negative 6 times 2 minus negative 4 times 5. That gives me negative 12 plus 20, which is what? 8. So my determinant is 8. So that means I'm going to multiply by 1/8 on the outside. Now we're going to do our swapping and our changing and all that stuff. So as we know from the rule, diagonals top to bottom, what do? Swap. And diagonals bottom to top, signs. Everybody good with that? Now we're just going to get it multiplied by 1/8. 2 over 8 reduces to 1/4. 4 over 8 reduces to 1/2. Negative 5/8, can't do anything with that. And then what would negative 6/8 reduce to? 3/4. Negative 3/4. So do we have any questions about how we got the inverse? All right, what I want everybody to do now is to take a second. I'll pause it. Go ahead and confirm the identity matrix by multiplying A times A inverse and confirm that you get the identity. So this is what I have so far, and then I'll just go ahead and condense and simplify that. I'm going to go ahead and pass out your homework for a second before I do that.
And some of the drawings that I could just leave and let them work on that.
Who did?
Mr. Norman.
Oh.